Okay, our third and fourth item we're going to go over is adding and subtracting. Obviously, I ran out of room on our last paper right there, and so I kind of switched to a new paper. I will post pictures of both at the end here. So adding and subtracting, what we need to remember, and we've done this before, is radicals must be like terms. So radicals must be like terms. That means the index and radicand have to be identical. That is incredibly important. If that index and radicand are not identical, you cannot add or subtract them. They must be identical in order for you to do that. Otherwise, they are not like terms. So we're going to have 3 examples here. Example 1. Our first example, we're going to say 12 root 5 plus 6 root 7 minus 2 root 5. Let's go plus 8 root 7. Now, I've shown you guys my trick before that I actually physically draw out on the paper what are the like terms. So I'm looking for, again, index and radicand being identical. All right, all of these have the same index. Awesome. So I'm only looking at the radicands. Well, root 5, I'm going to underline that, is right there. This is root 7. They do not have the same radicand. That means they are not like terms. However, negative 2 root 5 is a like term with 12 root 5. Those go together. Let's find my other like terms. I have 6 root 7 and 8 root 7. Those are like terms. I'm going to add these 2 together, and I'm going to add these 2 together because they are like terms. I know I've said that a lot. Hopefully that means it is important and you recognize that. All right, well, 12 minus 2 is going to be equal to 10, and the root stays, so 10 root 5. 6 plus 8 is equal to 14, a positive 14, and so I'm going to add 14 root 7. This is my simplified answer. I cannot simplify any more than I already have. All right. Example 2. Let's get a little bit more complicated. Let's add in a couple different indexes here. We're going to go the third root, or the cubed root of 4 minus 8 times the cubed root of 4, again, plus 5 times root 4. All right, well, again, we must have like terms to add or subtract. Index and radicand must be identical. Well, in this problem, I see 2 different indexes. I have an index in the first 2 of cubed roots, and I have an index in this last one of a square root. Note that all the radicands are alike. You cannot just see the radicands and say, oh, all 4s. That means that, they're all alike. No, both the index and radicand must be identical. I'm going to actually add that word in, both. Both index and radicand identical. All right, so I can add these 2 together right here, and that one stays alone. So let's actually add that. I'm going to go cubed root of 8. Now there's an invisible 1 here, so we are working with 1 minus 8, which is a negative 7, and a cubed root of 4. That does not simplify anymore. Now, this is actually a little bit different one because the square root of 4 does exist. The square root of 4 is 2. So this is really plus 5 times 2. And that exists. So our most simplified answer is going to be, and I'm actually probably going to put this first just to have it just be in the front, a positive number here. 10 minus 7 cubed root of 4. And that is our most simplified number. All right, our last example I'm going to show you here with adding and subtracting is actually just going to be a bunch of numbers here. We have 3 times root 98 minus 2 times root 32 plus 8 times root 18. Now, when you are working with numbers, now these are all square roots, so that makes it a little bit better. If none of them are similar or none of them are identical, you're going to have to simplify first and get the radicals and get the radicans to be identical. So let's break these apart. Well, 3 times root 98 can be broken apart into 49 times 2. All right, minus 2, and 32 can be broken apart into 16 times 2. Looking at pretty similar radicands in the second part of both of these. So I'm probably going to look for something that if 18 can be broken apart by something times 2, which it can, looking at 9 times 2. And now we see how these are going to simplify because 49, root 49 is 7. So I have 3 times 7, root 2. Minus, well, root 16 is 4. So minus 2 times 4, root 2. And root 9 is 3. So 8 times 3, root 2. All right, lots of simplifying going on here. This is actually kind of where it's fun. This is fun for me. I enjoy this part of it. We have 3 times 7 is 21, root 2. Minus 2 times 4 is 8, root 2. Plus 8 times 3 is 24, root 2. All right, 21 minus 8 plus 24. And that gets us to, let's see, 37 root 2. It's kind of fun for me. I like seeing how this entire expression up here gets simplified to 37 root 2 just by using all of our rules here. So that is addition and subtraction along with multiplication and simplification of radicals, 6.5 part 1.